Hi everyone, I hope you're all well and welcome to today's video. Well, the first video that I have ever uploaded. In this video, we are going to be talking about the Final Capstone Activity in the Cisco Ethical Hacker course, where I'm going to be taking you through the methodologies that I use to solve each of the 4 challenges. You are most likely going to be watching this video on YouTube, so I will have separated them into different chapters. I believe that is what they are called. So if you want to skip over to a specific challenge, then feel free to do so, but it will be best if you went through each of them. Anyway, let us start with the background, which says that you have been hired to conduct a penetration test for a customer. At the conclusion of the test, the customer has requested a complete report that includes any vulnerabilities discovered, successful exploits, and remediation steps to protect vulnerable systems. You have access to hosts on these 2 networks. You will see why you have these networks and the roles that they play. With that out of the way, let us start with challenge 1, which is all about SQL injection. For this first challenge, we have been told that in this part, you must discover user account information on a server and crack the password of Bob Smith's account. You'll then locate the file that contains the challenge 1 code and use Bob Smith's account credentials to open the file at this given address, which, spoiler alert, is a server, or I believe it is a server's address, to view its contents. And it is worth 25 points, so if you're into points and stuff, then let us grab these points, shall we? Anyway, the step 1, the setup. We are being told that we should open a browser and go to this website. So what I'm going to do is just copy this IP address and navigate to my virtual machine. This is the Kali Linux VM that is being provided in this course. You can use whichever, you can use any distribution that suits you, but it would be best if you used their own so that you can follow along. I'm going to open up Mozilla and navigate to that address. So paste it here. As you can see, it takes us to this login page. This is called the DAM Vulnerable Web Application, DVWA, and it is used for practice by anybody in cybersecurity. So as for the credentials, let us go back to this. Yeah, you can also use the URL if the IP address does not work. Anyway, we are supposed to log in with these credentials, which is admin password. So go back, admin password. This is the layout of the website. As you can see, there's a description, instructions, all that. And on the left, we have the different kinds of web application attacks that you can execute. And we're going to be going through some of them. So here we have been told to set the security level to low and then click submit. What I like about this website is how customizable it is. So as you can see, we are able to even configure the security level. So at first it was impossible, but we have been told to set it to low so that we can demonstrate the SQL injection. They even told you how each security level affects the website and the attacks that you might be trying to simulate. So click submit, and as you can see, now it has been set to low. Step 2, we are supposed to now retrieve the user credentials for Bob Smith's account. And we're being told identify the table that contains the usernames and passwords, locate a vulnerable input form that will allow you to inject SQL commands, and then retrieve the username and password hash for Bob Smith's account. So we know that we are going to be performing an SQL injection specifically to retrieve Bob Smith's credentials. I'm assuming that by the time you have been to this activity, you have gone through the SQL injection bit of the course, so I'm not going to go through that. what I'm going to be taking you through are the different payloads that you can use to try and gather all this information, because remember, at the end of it all, in ethical hacking, penetration testing, you actually always start with reconnaissance and collection of data. And to do this, we need to execute different payloads so that you can have an idea of how the database has been set up and if it is even SQL based in the first place. I have copied them here just for reference, and we're going to be starting with the first one. All these are in the course, by the way. I was just using them for reference, but there are a number of payloads that you can use. I just found these ones helpful because they were directly linked to this course and they were quite useful in solving this challenge. Now I'm just going to copy this, and then we are going to go to the SQL injection part where we have this form, if we might call it a form, just an entry field. Paste it here. Before you click submit, let me just go through what this means. The first apostrophe, I believe it is an apostrophe, it is just used to close the input. Assuming that this is an SQL database, there should be a section in the SQL statement that requires an input, and it is usually marked by a single quotation mark. So we are putting that as apostrophe, or rather single quotation mark, let me just call it that, to close that so that we can write a new statement. And this other section is a Boolean statement, which is always true because it says, oh, 1 is equal to 1. As you know, 1 is equal to 1. That is where we are, so that it can always be true. Regardless of what the statement says, this part will always be true. We also use this symbol to comment out the rest of the command. So if this payload is inserted in an SQL command, then this part will always be true, and anything after this symbol will be commented out. So we will only be left with this part, and as a result, it will always return the details of the underlying SQL database. So we click submit, and as you can see, we now have the different tables, if I might call them, being listed. We have admin, we have Gordon Brown, we have HackMe, we have Pablo Picasso, and finally we have Bob Smith. We now have an idea of the data that we have in here, and as I said, in reconnaissance this is important because it helps us understand what type of data we are dealing with. So since we now know that, we can proceed to the next payload that I noted down, and this is just going to show us, let me just copy so that you can see what happens. This is typically used for us to know how many columns the table has, because once you know the number of columns, all these are more or less building blocks for us to know how the database has been set up. So we have used order by one so that we can have one column being listed. So we can just keep on incrementing it until we receive an error so that we can know how many we are dealing with. So we have that. So we'll go to 3. As you can see, we have an error. There is no column 3, so the table has 2 columns. We know that now. Having known that, it's time to go to the next payload. Yeah, it will be difficult for you to see it here, so let me just open a new tab. As you can see, this is similar to the first one where we have this first part to close out the user input, and then we have a Boolean statement that will always return true, and union will just allow us to execute this. It is more or less used for entering another SQL statement, and here we are selecting, actually this union, in this case it will be used for us to append a new entry into the table, and the new entry is represented by this part here. If you remember, in the previous payload, we realized that the table has 2 columns, and this means that in every select statement that we use, we are going to have to input 2 fields, the first column and the second column. The first one is 1, which is just a value that we can use. You can use whichever value, but 1 is the one that worked here. Our point of interest is here, version. This is, you can call it a keyword, and it has been used for us to get the version of this database. And of course, this last one will comment out, sorry about that, it will be used to comment out everything else afterwards. So this payload is just for us to get the version of this database. So we have that, submit. As you can see, at first it returns all the data that it has, because remember that the union keyword was used to append the extra information. So as you can see, the last information here is 1, the one that we wrote, and the other one is the version. So we know this version, and this bit over here tells us that it is a Debian type database. So we know for sure that this is an SQL database. On top of that, we have another payload. I'm just going to execute this payload so that you can see where we are going. This is similar to the previous one. The only difference is that we are using a different keyword. Instead of version, we are using database, so that at least we can get the name of the database that we are dealing with. When we submit that, again, it appends this extra information down here. So again, 1, and then the name is DVWA. So we know for sure that this database is called DVWA. So we know the version, we know the name, we know how many columns the table has. This is reconnaissance. We are gathering a little bit of information. Next, this is a bit lengthy, so I'm just going to describe it. The first section is more or less similar to the previous ones, and then we are going to be appending this part here. So again, we are using 1 as a default value, table name, the name of the table. Most of this is self-explanatory, but where we're getting the name of the table is from this here, which retrieves the metadata for the tables that are in that database. And this metadata, we are getting it from the base table type. This is just another keyword that is used for the different kinds. It is just used to return a normal kind of table, because there are different kinds of tables in an SQL database. To keep it simple, this just returns the normal table. And then we are only limiting the results to the DVWA database, since we already found its name. So we are only interested in the data that it has. So I'm going to copy this. Here we go. Notice what happens. It has appended 2 bits of information: guest book and users. Now we know that the DVWA database has 2 tables in total. Just from the names, you can already guess that the users table is the one that will be of most help. So that is what we're going to be focusing on. But this was just to show you how you can identify the number of tables that the database has. So we go back. This is similar to the previous one. This time we are just going to, as you can see, the entire bit here is similar to the previous one. The only difference is that now we are retrieving the columns for the users table. Since I told you that the users table is the one that is of interest, it is the one that is likely to have the user credentials. So this is just to say that we are always going to return this, and then in the results that we get, we append the columns from the table that is called users. So I'm just going to copy that. By the way, in case any of this sounds a bit daunting, then all of that is contained in the course itself, so you can go through it in the labs, and then you can have a better idea of why they have been framed that way and how you can manipulate them to do many other stuff other than this. So I am going to paste that. So let us see what information has been appended. As you can see, quite a lot. We have the user ID, we have the first name, we have the last name, we have the user, we have the password, we have the avatar down here, last login, failed login. What does this tell you? It tells you that we now know that there's a password column in the users table, which is likely to have the passwords. Now that we know that, we go to our last payload, which will retrieve the information that we need for this challenge, and it is simpler than the previous ones because it is quite specific. We are saying that we are always going to return a true statement, and in the results that we get, we are only interested in the username and password columns from the users table. Let us see what kind of magic will be conducted here once we hit submit. Unknown column username. Oh, sorry about that. It is not supposed to be username. Let me correct that. Let us use this one so that we can. It is supposed to be user, not username. Right, so let me just retrieve it. I did it again. I did not edit it. Yeah, that should be correct. Yes. I mean, now you know what you need to look out for when doing this kind of simulations. Anyway, what we find is that some data has been appended to the results, and as you can see, this corresponds to what we have initially. So the first one is admin, and this is the password hash. I know, right? This means that now we have a list of the users and their corresponding passwords, and the activity told us to find the password for Bob Smith. So Bob Smith is the last one, so the last one here is Smithy, yes, and this is the password hash for Smithy. The question is, what do we do now that we have the password hash? We go back to the activity where the last step is to use any password hash cracking tool desired to crack Bob Smith's password. There are a number of tools you can use. You can use Hydra, you can use Hashcat, but to keep it simple, I'm going to be using CrackStation, which is useful if you already have the password hash. What I'm going to do is copy this hash and then go to CrackStation. So remove that. There it is, crackstation.net. Let us solve this challenge. We select the bicycles. Now we paste the hash, and this website does a great job at deciphering what hashing algorithm has been used. So we crack this hash and it has successfully done it. It even tells us that this was hashed by an MD5 algorithm, and the ciphertext, or rather the plain text, is password. So now we know that Bob Smith's password is, well, password. And to prove that, we are going to log out of this website and then log back in as that was the username, and then password is password. We are in. we are in as Bob Smith. As you can see, the username is Smithy. So now we know that this was the correct password. So what was the password? I already did it, so I filled it in. Now the last step in this challenge is to locate and open the file with that. We're going to be logging in as Bob Smith. If you found this confusing, then this is quite simple, since most of the time if you are given an address in the context of cybersecurity, then more or less it means you need to log in remotely, and in this case we are going to be using SSH. So I'm going to copy that address and go to open my terminal and type SSH. The username is Smithy at this address. So it should request a password, and we already have the password, so I'm going to type in password. We are in. As you can see, the username has even changed. It is Smithy at Metasploitable. We have been told to locate and open the flag file in the user's home directory. As you know, when you log into a device via SSH, by default, most of the time you're going to be located in the home directory. So I'm just going to check out what we have in the home directory, and also this symbol over there shows us that we're in the home directory. We can even use pwd to prove that. So yeah, we are in home. So I'm just going to use ls. We have a text file, my passwords, which is likely to have what we're looking for. So we print out the content using the cat command. So cat my passwords. And we have a message which tells us that we have solved the challenge. So by this point now you have everything you need. So you're just going to copy the message or the code, whichever you need. And that is how you solve, that is one of the ways that you can use to solve this challenge. So you can use that to answer these questions. What is the name of the file? What is the message contained? For this last question, there is this website that does a great job at explaining the remediation measures for SQL injections. It describes everything you need about SQL injections, which is why I highly recommend you go through it. And there's this section here, the 9 best practices to protect your database from SQL injection. If you're in cybersecurity, or if you build web applications, then I highly recommend you go through this, because they have done an amazing job at explaining this. So I'm not going to go into detail. That is how I went about it. I am curious to know how you solved this challenge. With that, let us move on to the second challenge. In the second challenge, we are being told that we need to find vulnerabilities on an HTTP server, and the misconfiguration of a web server can allow for the listing of files contained in directories on the server. You can use any of the tools you learned earlier to perform recon and find those directories. What this means is that there are some websites that allow anyone to view the files that are being hosted on it. And why this is dangerous is because, similar to the previous challenge, if an attacker knows the layout of your files, if they know what kind of files you have, then it will be easy for them to map out and execute a precise attack. So for our first step, we need to log back into the same website with the same credentials and set the application security level to low. So I'm just going to go back to my VM, and then we can exit here. We'll go back to Mozilla Firefox. Let us see what the security level is. It is still low. Next, let's go back to the question. From the results of our recon, determine which directories are viewable using these sorts of manipulation. To do this, you can use two tools. You can use, actually there are a number of tools you can use. Again, you can use GoBuster, but I'm going to be using a tool known as Nikto. So you can just use the man command to learn more about Nikto. it is. There are a number of options that you can use. For us, we're going to be using host because we already know the IP address of our host, which is that DVWA website. So you can just quit that, clear. So the command is nicto, the host, and what was the IP address of our host? Let's just copy it to make it simple. It is going to scan the website and tell us which directories are publicly viewable. So as you can see, it has already returned 1, 2, 3. Yeah, there are a number here. Let us wait for it to complete the scan and then we can begin checking them out. Nice. So we have a number of directories here. So I'm going to go through them one by one and see what content they have. So we're going to start with config. So just going to select a new tab and then this /config. It has these directories, so you can just go through them it has all those files. You can go through them one by one. For some reason this one is not loading, so it is not really helpful. We go to dbform.html and already we have solved this challenge. This is how you would have gone about it. You can check out the other directories and it shows you how easy it is for an attacker to know the files and even access the files of a vulnerable web server. So since now we have this flag, you can use it to answer these questions: which directories can be accessed, you can list them, which directories can you look for the file, you can list the ones that we had. One of them is config. You can also use docs. What is the file name? It is dbform as you saw, and which subdirectory was holding it. It is config. For the message, you can just copy paste that message. And now this, you can just look at the remediation steps for directory listing. I said that you can disable it in your web server configuration to prevent anyone from viewing it, and you can also ensure that each of them has an index file just to keep their private information hidden. That is it for challenge 2, so on to challenge 3. In the third challenge, we are going to be exploiting open SMB server shares, where we are told we will discover if there are any unsecured shared directories located on an SMB server in this network, and we can use any of the tools we learned earlier to find the drive shares available on the servers. So the first step is to scan for potential targets which run SMB. For this, I'm going to navigate to my VM, and then we're going to be using nmap. So I had already set up the command, and this command uses the nmap tool, where we're going to be scanning specifically for these 2 ports. That is why we have -p. I think that is how you can describe it in layman's terms. We are using 139 and 445 because they represent the SMB protocol. I believe that 139 is SMB over NetBIOS. So, but mostly you will get to learn SMB uses 445, and then we're going to be using it for on this network. Let me confirm that this is the IP address that was used. Yes, this is the one. So let us scan so that we can know which host in that network is running SMB. So let us go back and run this. Let us give it some time, and it should return at least one host that is running it. We have a number. Most of them are closed. So as you can see, most of these are marked as closed. As you can see in the state here, closed. However, one of them has both of them open, and here it is. As you can see, it is 10.5.5.14, and it has both of them open, which means it is actively running SMB. We will take note of that because it will come in handy in the next step. So which host has open ports? it is that one, because it has, as you can see, it has both of them open, which indicates that it is running SMB. Determine which SMB directories are shared and can be accessed by anonymous users. Use a tool to scan the device that is running SMB and locate the shares that can be accessed by anonymous users. For this, I'm going to be using Enum for Linux. It is one of the tools that you can use for enumeration, specifically for SMB Windows devices, and this is the command, Enum for Linux, and then you indicate the target host. You can also use -s. Actually, we can just go through the manual a little bit so that we can see what there's no manual entry anyway. Let us just use this command. This is what it will tell us. Let us give it some time for it to complete the scan. It will give a comprehensive layout of what shares are being run. It is almost done. And it is done. So for this challenge, we are only interested in the file, in the shares that are here. So this is where we are going to be focusing on the share enumeration on this target. As you can see, we have the homes, work files, print, IPC. Now to understand, let us actually answer the question first so that we can move on. What shares are listed? It is the ones that I have highlighted. Those are the ones that are listed on that server. Yeah. And for the third step, investigate each of them to find the file. So we need to investigate each of those directories so that we can find the file that we have been told to locate. We are supposed to locate the one with the challenge 3 code. For this, we can use the SMB client utility, because it is what will allow us to access them, because the point is to also know if we can access them anonymously. Yeah, I'm trying to access the command that I used some time ago. Here it is. So use SMB client / and then the IP of the target. Afterwards, now you can indicate the specific share that you are trying to access. If I go back here, now we have home, so we are going to be accessing them and seeing if we find anything interesting. So the first one is going to be homes -n. So what does it have? We can successfully log in, but we cannot see the content, so we know for a fact that homes is invalid. Next we go to work files, so I'm just going to edit that. We are in, because as you can see, this has changed. Now it is SMB, which indicates that we have successfully logged in. It does not really have any file that we can access, so we can just exit that. So work files again is not as useful. Now we have print. We are in, so let us see what print has. It has quite a bit of information. It has all this, but notice that there is this one named other that was also handled on a different date, which means that this could be of interest. So let us navigate it and see what it has to offer. So cd. Now it is similar to Linux, so that is why I'm using the Linux commands. We can see that it has a file, and this file has some information. As you can see, this is not 0. So what we need to do is use the get command to download it on our remote machine, or rather our local machine. This is a remote server. We are accessing that information, that file, and retrieving it. So we are using the get. It is done. So we can exit and then ls. Here it is, as you can see. So let us use the cat command to see what it has. There it is. That is how you needed to go about it, to access the SMB shares, to check whether you can, any anonymous user can access it, and if that is the case, how you can retrieve the files that are stored on them. So since we have that, I believe that we are done with this challenge, and you can answer these questions. In which is it found? We found it in print. What is the name of the file? Here it is. Enter the code. Well, you have the message, so you have the code. And how to remediate SNB attacks. There are quite a lot, but I only wrote 2. You can update and patch your servers, and you can segment your network so that different types of devices have different levels of access. So we have printers, we have servers, we have all different kinds of devices on the network, and that is where we are able to access the information. With that, now we are left with only one challenge, the last one, which is analyzing a pickup. I'm not sure if that is how you pronounce it, but a network traffic file to find information. In the last challenge, we are going to be analyzing a packet capture file. That is what this pickup represents, to find specific information. We are being told that as part of our recon effort, the team captured traffic using Wireshark. The capture file, named sa.pickup, I'm not sure again if that is how you pronounce it, is located in the downloads subdirectory within the Kali user home directory. So in short, this file is located in our downloads directory. The first step is to find and analyze it. So we're just going to go to our virtual machine. We're done with this, we can click that. So navigate to the downloads directory and see what it has. There it is. So to open this up in Wireshark, we're just going to enter the Wireshark command and then the name of the file, so that we can launch Wireshark and open this file. There it is. For some reason I cannot enlarge this, but anyway, here is, we have all this information, but we have been told that we need to analyze the content to determine the IP address of the target, and also we need to display the content of the directories of the target computer. When you are told to look at traffic, depending on the nature of the challenge, most of the time you're going to be looking at the HTTP or HTTPS traffic, because packet capture files contain a lot of information. So what you can do is to filter this. So you can put in HTTP. So now we have HTTP only traffic. As you can see, it is all HTTP. And let us first answer the question. We analyze the content to determine the IP address of the target computer. To do this, we need to look at the first, because for a GET request, as you can even see the direction, for the GET request, we are requesting data from a given server. So the target of this, the destination is this IP address over here. You might have a different value, but this is what I have. And as you can see, this was getting something from a database. When I did it, I had a different value, so yours will likely be different. what directories on the target are revealed in the pickup. Well, there is data. I'm going to show you where that is. So we have this database offline. Actually, no, that is the file. We have style/global styles, we have test, we have data. So we have all these different directories, so you can list them there. And then we have been told to use our web browser to display the contents of the directories on the target computer. So we need to use our web browser to investigate the URLs listed in the Wireshark output, and we need to find the file with the code for this challenge. So in short, what they're telling us to do is to access each of these, and I mean, you could go through all of them, but as you can tell, data is one that is likely to have the most useful information. But then again, we have a directory, but what about the URL? What about the rest of the information? To do that, we can click this, and then now we can do what we call following the HTTP stream. In short, we are following the paths that this packet took so that we can have the information about this connection. So click that, and we have this. As you can see, this has HTML code, it has the headers up here. Notice this. We have been told that the document has moved specifically to this address. And as you can see, we have data. So the directory that we had in mind is here. So we're going to take this URL, and then using Mozilla, we're going to navigate there and see what we have. As you can see, we have user accounts, which signals that this could be a file of interest. So when we click that, we find that here's the code for challenge 4. There's the code, which means that we have successfully completed not only the 4th challenge, but all of the challenges. So let us go back and see what questions we have. So what is the URL? Here it is. What is the content? You can copy the XML content. What is the code? It has been provided. And research and propose what are the remediations for transmission of text as clear text. All the points you're going to list will be summarized by one word: encryption. And with that, we have completed the final capstone activity. I am curious to know how you manage to solve the challenges in your own ways, and I hope that you found value in this video, because I did. And yes, that is just a rundown of how you could have, one of the ways that you could have used to solve this challenge. And yes, that has been a walkthrough of my methodologies, and I hope to see you for the next video, whatever it will be. And thank you for watching up to this point. Bye bye.